Okay, this is assignment 2.1.8, the photoresistor. We're going to use a photoresistor to control an LED. Okay, now photoresistor is a light-controlled variable resistor. Basically, it varies resistance based on the amount of light that is hitting it. And it exhibits a type of thing called photoconductivity. All right, so basically, if it's kept in the dark, the resistance is very high. Basically, the resistance can be as high as 10 to the 12 ohms, which is like 10 to the quadrillion or trillion ohms, basically. All right, so it has lots of resistance, basically, when it's dark. But as light hits it, basically, the resistance decreases and allows electricity to flow and the circuit to have some amperage and so forth. Again, if we remember our Ohm's law here, again, as the resistance decreases here, the voltage the voltage or the total current here will increase because the voltage stays the same. So this number here will get bigger and bigger and bigger. But if the resistance is really high, of course, then this will be a really small number. There'll be no current, basically. So basically, that's kind of how it works. And we uses a material called cadmium sulfide, basically in a kind of a wiggly track here to kind of capture the light. So that's how it works. All right. So what makes this, so what's good about this, of course, is that you can measure the amount of light that's hitting it. So you can basically do different projects that require any kind of light-sensitive kinds of actions or material, or things you want to do when light hits something. So again, that's what we're going to be doing. All right, so for the parts for our assignment, we're going to need, of course, our Arduino board. We're going to need a breadboard, the photoresistor, 330 ohm resistor, 10K ohm resistor, a yellow LED, and 6 jumper wires. Okay, so let's go ahead and put together our virtual circuit, and then we'll start coding to kind of show you how that's all going to work. Okay, so we have our Arduino board here and our breadboard, and then we just need to get the rest of our components. Let's start with some resistors. Okay, we need a 10K resistor, so I'm going to make this 10K. All right, we also need a 330 ohm resistor. So let's change this to 330 and then change that to ohm. All right, we need an LED. Let's make it a yellow. Okay, and then we need a photoresistor. So we just type in here photo. There we go. And there's our photoresistor. All right, so that should be all of our components. Now we just kind of start setting things up. Okay, so I'm going to start by rotating my photoresistor here, and I'm just going to stick it someplace here at the top, maybe down one more. All right, so we're going to put that there. Let's put our LED in there next. So we'll put that down here someplace. Okay. Now a LED gets hooked up the way it normally, or the way it hooks up all the time, which is again the negative side gets attached, or the negative, the cathode pin of the LED gets hooked up to the resistor, which then gets put into the negative channel of our breadboard. So put that one like that. All right. Now, the way the resistor and the resistor with the photoresistor works is that when the photoresistor basically is dark, it has no light on it basically, we can assume that's also about a 10K resistance. So it's pretty high basically. 10K is pretty high. 10,000 ohms is pretty high. So what happens is that we put a 10K resistor with in line basically in the same kind of with the same kind of a connection as the photoresistor here. And then as light hits the photoresistor, basically the photoresistor starts to decrease in resistivity, decrease its resistance, but this stays the same. And what we're really doing is kind of measuring how much of a change there is between the 10K that we kind of start with the photoresistor, and then how it gets less and less and less. All right, so that's basically, so we're going to, let me get my resistor here. So we're going to hook the resistor into one end of my channel here. Actually, let me move it over one. There we go. All right. So in the same channel here is one leg of the photoresistor. It's going to be the 10K, because again, we're going to be measuring the the difference between these two basically. And we're going to be doing that on the analog pin A0 here, because again, this is going to be kind of an the resistance changing over time is not like an on or off thing, so it's not a digital kind of measurement. It's an analog. It's going to change, vary over a small degree, a little bit at a time. All right, so let's finish hooking up these. All right, so we're going to hook up the other end of our resistor here, our 10K resistor, to our positive channel here. Let me make that, I don't know, blue. Okay. And then we're other leg of our photoresistor here. We're going to kind of take that out, and I'm going to run that all the way around to the analog pin here on our Arduino board. Okay, so and again, let's make that something else here. Let's make that purple. Okay, now we're going to take oops, I'm sorry, this needs to be in here. All right, yeah, because we were trying to measure the analog off of the resistor pin here. So okay, so yeah, so we want to make sure that the analog pin on our Arduino goes to the same pin as the same channel here as basically the resistor pin leg of our photoresistor here. All right, yeah, the other leg here just goes into our negative channel here. So let's make that black so that we have that one in there. All right. Again, we've connected up our negative channel here, so now we just need to hook this up to a digital channel so we can turn it on and off. So I'm going to run this one up this way, come across here, and I'm going to hook it up to the 9 pin. There we go. Let's make that pink. All right, so our LED here, again, we're just going to be turning that on and off basically. So anyway, so again, the negative channel goes to the negative, and the positive channel goes to our 9 pin on our digital 9 pin on our Arduino board. The last things, of course, we have to hook up is our voltage and our ground for our Arduino board here. So we're just going to run this over to here, put that in there, make that red. Kind of line this up a little bit better. All right, and our ground, just going to run this one down here, come across here, and into there, make that black. Again, kind of line this up a little bit better. All right, so again, our 5 volt and the ground, of course, off the Arduino board goes in the positive and negative channel here, so that we our circuit gets the positive and negative connections to get it going and so forth. And then basically that's it. So that's kind of how it works. Okay, so again, we're not really using pulse width modulation on this one, but we're just, a little talk about digital versus analog. Again, analog can vary, up and down and so forth. So it's not it's not kind of an on or off kind of a signal. So basically, again, with a digital signal, it's either on or it's off. 1 or 0, but analog can fluctuate and so forth over time, especially. All right, we're also going to be using our serial port again to kind of monitor the light level, so we keep track of how bright or dark things will get. So that's why we'll be using that. And again, it'll help us determine when to turn on the LED and when to turn it off. All right, so again, comment first, code last. For this particular sketch, basically this particular program, we're going to be using a photoresistor to control an LED. In front of the void setup function, before it, not inside of it, we're going to create 2 constant variables, one to represent our analog pin and one to represent the digital pin that we'll be using. We'll also need a variable to control the light level of our LED, and we'll set 3 global variables for that. Okay. Now inside the void setup function, we'll type the following comments. Again, we want to set up the digital pin to be output. We actually don't need to do anything for the analog pin because it'll be sending us information. So, but we want to set up the serial monitor also for output. So make sure we write all these comments in there, and then we can move on. All right, now inside the void loop, we're going to type the following comments. We're going to use comments here to disable some examples. Again, we use comment. We're going to create a couple functions, different functions, and we'll use the functions to kind of control the LED, or to use the photoresistor information to control the LED. All right, we'll be using an analog read function to measure the voltage coming from the photoresistor. And again, this can range anywhere from 0 to 1023 or 5 volts. So basically it's the voltage coming off of it. But it can, the circuit of course can have a smaller range between dark and light. So we're going to set up a way to kind of keep control for that too. All right, and again we're going to start setting the light level variable to the amount of light which is striking the photoresistor. All right, now we're going to be using two different functions to control the LED. First one is going to be a manual tune function, and the other one will be called auto tune. For the first function, we'll use a serial monitor to actually manually figure out kind of what how bright the light needs to be to turn the LED on, and then how bright to turn it off, and so forth. So the manual tune function again will help us to determine what light level to set, and the auto tune function again will change the light level for us automatically using the Arduino and coding basically to do that for us. All right, so now once we have the light level variable, it's going to be based on whatever it's coming from the photoresistor, so we can use that to set the LED brightness. Okay, we're going to be using the map and constrain function. So the map, again, if you remember, I don't know if we talked about these already or not, but the map function and constrain functions help us to control what our numbers are that we send to the analog, or what we get from the analog write function and the analog read function and so forth. All right, so basically our analog read function is going to be going from 0 to 1023, but for our analog write we can only go from 0 to 255. So map helps us to kind of squeeze this range basically into this range. So it kind of does the math for us and does the calculations and everything for us automatically, and it keeps us from and kind of, you know, does that so that we get what we kind of get a kind of a mapping. That's why it's called map, obviously, to from one to the other. And the constrain function basically keeps us from getting outside the range that our function can possibly go. So for example, again, we need our number needs to be between a 0 and 255, and if for some reason like the map function doesn't quite map it exactly, say it goes like 257 or something, the constrain function just makes sure it goes only to 255. Constrain keeps our values between 0 and 255, and that way we keep from getting an error. All right, so our manual tune function, the comments for we're going to set that up. So you know, put that into your program, and inside there we're going to put in these comments. Send information from the photoresistor to determine what values use for our light variable. And again, we're going to use the map function to squeeze the range down from the analog read data into a smaller analog write range for that. And then we're going to also use information from the serial monitor to determine what values change and so forth. All right, and then we use a constraint function to set the upper and lower limits of the range so we don't have an error. Now we can set up our auto tune function. So set up the auto tune, start by creating the auto tune function. And then inside there, we're going to put in these comments. Basically, we're going to use this function to take the information from the analog read and automatically determine our light, our values and so forth. Basically, we're going to use a low variable to determine what our lower limit of the range would be, and a high variable for the upper limit. And what we do is we set the low variable to be the highest number, because that way anything lower than that, which it obviously will be something lower, we'll put that into the low variable. The same thing with the high. We're going to set the high to the lowest value, and then anything higher than that obviously will get put into the high value. And what we do there then is basically we just change the variable. We change the value of the variable as the light levels change. And basically we'll kind of zero in on our lowest value and our highest value by doing that. So it's actually a pretty good kind of logic way to do this kind of thing. Okay, so for the auto-tune function, we're going to add an offset to the low and the high, basically to finish that up, and ensure the LED is kind of fully off or fully on at the limits. So that's we're going to just add that a little bit more. Then finally, for the function, we send the values of the high and low variables to the serial monitor just to double check to see if they kind of fit with what we're expecting. All right, so before we start coding, we're going to use test-driven development to kind of test our code and see what's... Okay, so again here back at our virtual circuit, we're going to look at our code here, go up to the top. So again, we've typed in all the comments, we've created the setup function and typed in their comments, we've created the void loop function, typed in the comments for that, the manual tune, typed in the comments there, auto tune, typed in the comments there. So again, we just have our comments typed in, so we don't expect our circuit to really do anything, but we're just checking for errors right now. So we click to start the simulation, and the program's running here, but again, it's not really doing anything yet because we haven't really told it to do anything. It's just checking the comments, okay? Okay, so now it's time to code. So if we start by creating a couple of constant integer variables to represent our pins on our Arduino board. So we need one for the sensor pin, which will be the analog pin, 0, and then we need one for the LED pin to turn the LED on and off and so forth. And then we're going to use the PWM pin 9. Okay, so because we're actually going to kind of adjust the brightness of the pin based on kind of the amount of light we're getting from our photoresistor. All right, then we need a couple of our 3 global variables. We need light level, we need high equal to 0, and low equal to 1023 for when we do the high and low variables. We'll be using that in our auto tune section. All right, then under the setup function, we got to set our pin mode to output for our LED. So we turn that on, and we also need to set up the serial port. We have to turn that on also and begin that. So that's what those next ones do. All right, now under the loop command, the loop function, we're going to set our 2 different functions that we're going to be running for this particular program, the manual tune and the auto tune. Now the auto tune, if you'll notice, has been commented out right now, so it'll be a comment basically, because we don't need to run that one first. We're going to run the manual tune first, and then after we get that one working, then we'll come back and run the auto tune one. Okay, we'll change the comments on that. All right, so the first thing, the last thing we need to do for the loop is to write in there the analog write. Again, this will send to the LED pin the light level value that we have for our photoresistor. And then that will basically light up the LED brighter or less bright depending on what the light level is. Okay. All right, so let's go to our manual tune function. So now what we want to do is send information from the photoresistor to determine what values to use for our light level variable. So we're going to type in these code here. So light level, our variable, is going to equal the analog read of the sensor pin. So basically we're going to get some information from the sensor pin and store that in our light level variable. Now we need to see what those values are, so we're going to send those to our serial monitor. So we're going to print light level with a colon here, and then we're going to print line. We're going to add light level, and then we're going to end the line basically, so that each line has a different light level depending on how bright it is and so forth. So now we can open up the serial monitor to get the values for the lowest and the highest light levels. Okay. Now the next thing we want to do is we can put this code in there too. We're going to use the map function again to squeeze down the range. So for light level, so our light level is going to be equal to the light level variable, whatever value that is. But we're going to squeeze any values from 0 to 1023 down into two values from 0 to 255. Okay, so again, because we can only use 0 to 255 to send to our analog write values and so forth. So we got to kind of squeeze those down. And then also we have to make sure that we constrain our value so that, again, our light level value does not go above or go below 0 or above 255. Okay. And then again, what we'll do then is this information will return back to our loop function, and then it'll light the LED. So what you want to do is we're going to take this information first. So we're going to run the manual tune. We're going to monitor what's going on in our serial monitor, and then based on how bright or dark our values are, we can then set up our values for what we expect to light our LED. Okay, so here we are back here at our virtual circuit. So we've gone in and we've added our constant integer variables, all right, our global variables, set our pin mode, turned on the serial monitor. We're doing manual tune now, and then eventually we're going to write to our LED pin here and turn on our LED. So inside the manual tune function, we're getting the light level variable by reading the sensor pin, the photoresistor here. I'm going to send that to our serial monitor. I'm going to turn that on right now. So the serial monitor over here will get that information. And then based on that information, we will be able to map our values into the right things and constrain them correctly. All right, so let's go ahead and start our simulation here. All right, so here's our light level. So this is our maximum light level right now, I believe. So if I click on our light thing here, you can actually adjust it yourself. So here's the lowest value. So this would be like if you covered it up. And then this would be the highest, is like if you let it, be directly in the light of their thing. So as you can see, it doesn't quite get to the 1023 here. It only gets up to 696. And then if we go all the way down, it goes down to 49. So what we can do now is we can stop our simulation, and then we can change our values here. This is why we call it manual, because we're going to change our values to 49 and to, what was the other one? 969, I think it was, or 969. And then basically it'll map those values into our values for the light constraint here. And basically we should be able to light the LED and turn it on and turn it off and so forth. So now I'm going to close the code editor and see how well that works with a thing. So again, here we are, as it's bright out, so it's lighting up our LED. Now if I come all the way down, it should be a lot lower. It actually should be turned off here. That's what's going on there. And then anywhere in between here should light up the LED in different values, and that is what we expect. So again, that's what your code should be doing right now. Okay, so that's what you're going to do. You're going to run it, see if it does what you expect. If not, troubleshoot your code and your circuit, basically. See if what's going on, what's not working right. Don't forget, you're going to change the this command here, basically. You're going to change the 0 and the 1023 to kind of match up with what you get in the serial monitor. So again, you won't get exactly 0 and you won't get exactly 1023. You'll get some high number and a low number, and that's what you're going to change these two to represent those. And then your picture should, or your LED should light exactly like kind of we're expecting it to. And again, don't forget, you can, you click on your photoresistor here, you can actually adjust it in the virtual circuit by using the slider here to kind of do all that. Okay, now it's time to start coding the auto-tune function. We start with that by setting the light level variable equal to the analog read from our sensor pin. So basically we're going to pull in the information from the photoresistor and set that to our light level, and that'll get us started. Next, we're going to put in an if statement here to change our low variable based on the light level. So basically low is anything that's less than our highest value, which is 1023. So that'll be pretty much anything. So as the light level decreases or gets lower, basically that'll keep changing our low variable until we get down to the lowest possible level there. Same's true for the high, except we're going to go the opposite direction. So high starts at 0, which is the lowest possible one, and then any light level that is greater than 0 or greater than that value of high the high value keeps getting higher and higher and higher based on that. All right, so then another trick we do to kind of make sure that this all kind of works out okay is we're going to add 30 to our low value and subtract off 30 from our high value, basically to give ourselves a little wiggle room there. But basically we're going to map those values directly into our 0 and 255 so that our values only can go from 0 to 255. And we also use our constrain function to make sure that that doesn't go outside those that range, basically, so it doesn't go any less than 0 and any greater than 255, and that makes sure we don't get an error. Finally, we send to our serial monitor basically our high variable and the low variable, make sure that we're actually getting some data there, and also we can also then use that to kind of match up with what we got in our manual tuning of the photoresistor. So again, make sure to comment out the manual tune function with 2 slashes so that we don't start using that function. We're going to be using the auto tune function this time. Run it, make sure it does what we expect it to do. If not, troubleshoot it and fix it. And also watch the high and low values in the serial monitor, see if they match kind of with what we found when we did it manually. Okay, here we are back at the virtual circuit. So you can see here I've coded in the commands here for the auto tune. Again, the if statements here for the high and low variables, the map function, the constraint function, and the print things to make sure that that all works. So let's go ahead and start it. Start the simulation, see what happens. As we can see here from our the serial monitor, they're all the same because we haven't, the photoresistors has only been getting light right now. So if we slide it down here to get some dark, then that should change our low variable but keep our high variable, because again it's not changing anything. Again, we can go back up, and as you see, basically it is actually kind of matching up with what we did with our manual monitor. So now if we close the code editor so we can kind of see the LED, we can see that when it's the light is low, it's turned off, and when the light is high, it's turned on, and then in a kind of in between is a different shade for the LED. So basically, yes, everything is working kind of what we expect.